Good afternoon, everyone. Thanks for attending this session, SAP Solutions on vSphere, Best Practices. My name is Vas Mitra. I'm an SAP Solutions Architect with VMware, and I've been with VMware last 3 years, working with partners in SAP, developing SAP on VMware solutions and best practices. I've also do some pre-sale support as well. Prior to VMware, in a previous life, I have been an SAP basis admin. I'm going to hand over to Todd. He'll conduct the first half of the presentation, and I'll follow up at the end.
Hello, everybody. So my name is Todd Muirhead, like Vas said. I work in VMware's performance engineering group, focusing on Tier 1 applications. SAP is one of the applications that I've done quite a bit of testing on. But I've also tested things like Exchange and SQL Server and Oracle databases as well. So the net result of what I do is white papers, blog entries, and also feedback back to development as well. So when we encounter problems or issues, things that could be better, we will funnel that back in the form of bugs. The one last aspect, which I touch on in the talk to a certain extent, is that when customers do have performance problems and they go into support, eventually they're escalated to our team, and then we have to work with them to solve it, or, like I said, funnel things back into development to get them ultimately fixed if it's a bug. Other one. This is the legalese. So the agenda for today, I'm going to start off with a very quick overview of SAP on vSphere, and then I'm going to talk about performance from several different aspects. And as we go through these different aspects, I'm going to try to bring out some of the best practices that go along with these performance studies that we've done. So hopefully by the time I get done with the performance talk, we'll have also covered a lot of the performance best practices that we've come up with in the last year and a half or so. And then Vas will take over, like he mentioned, and do some sizing, monitoring, and then we have a video demo at the end. Okay, so one of the questions that comes up a lot, especially with customers, SAP customers that are new to virtualization or considering it, is the support question. And as you can see on the slide, it is fully supported by SAP. SAP has actually been a really good vendor to work with. They were on board fairly early in terms of providing support for their full suite of enterprise, not full suite, their enterprise applications on vSphere. But then there's also the issue of database support as well. So each of the individual databases that SAP supports are also supported on vSphere as well, but the support for those is deferred to the individual database vendors. So so Oracle is the one that comes up sometimes as a question: is it really supported? It is supported. There's a MetaLink article that has the details, and if you have detailed questions about that, I can follow up with you afterwards for more detailed information. Okay, so in terms of performance with SAP, the key metric that everybody uses, SAP customers use, is SAP's number, which comes from the SD benchmark, which is SAP's main benchmark. Up until vSphere 4.0 and the Nehalem and the Intel Nehalem and AMD chips supporting RVI, we were really limited to 2 vCPU submissions. So the only SD benchmarks that you see prior to that on vSphere at the time, I think they were referred to as ESX, were only up to 2 vCPU, and that was because when you went beyond that, the performance didn't scale. But like I said, with Nehalem and ESX4 coming out, we really saw the scalability increase a lot. And so these submissions were published about a year ago by Fujitsu. And you see really good scalability between the 4 vCPU and the 8 vCPU with it's nearly linear. It's pretty close. And achieving some pretty respectable SAPS numbers. The interesting thing about all this is, I think it's kind of interesting being a benchmark guy. There's specific rules with the SD benchmark that only allows you to publish certified benchmarks with a single operating system on a single physical host. So what that means for us, whenever you're going to do a benchmark with The SD two-tier benchmark on vSpheres, you can only have one VM on a host. And so we're limited to 8 vCPUs in that VM, and that's all you're going to be able to get in terms of a certified two-tier benchmark. But there's going to be more resources left on the host if you have more than 8 physical cores, which is becoming more and more common these days as the core count in servers continues to rise. So as you can see in this result here, even though this is in the Halem system, so it had 8 physical cores, but it actually has 16 logical threads. So we're leaving performance on the table by only using a single 8 vCPU VM. And as you can see, the CPU utilization for the host was not at 100%, even though this is a benchmark submission, and typically those are done as a high utilization as you can get. So that's kind of the caveat, and that's why you only see SD benchmark results up to 8 cores. What did I do with it? Here it is. Okay, these are the details, and there's legal requirements for when you publish or talk about an SD benchmark in public, so this fulfills those requirements. And it gives you a little bit more details. It was a Fujitsu system, Intel, and a Halem 2-socket. So the next way to look at this certified benchmark thing is SAP also has a 3-tier benchmark that you can do. So what that means is you now have application servers and database servers split out, more like real customers will be running any type of sizable SAP environment in production. These benchmarks aren't really commonly done. They're a lot more difficult to do by the partners that actually do the certifications. So you don't see a lot of them. But in order for us to get the full performance out of a box that's running virtualized, we really needed to see a 3-tier benchmark on vSphere to show that, yes, we are capable of doing these higher levels of SAP's numbers. So we worked with Fujitsu, and when I say worked with, they did the vast majority of the work. They're the SAP benchmark gurus. I provided some support in terms of the vSphere side of things. We were able to achieve a pretty impressive 3-tier number, which is much, much higher in terms of number of SAPs and users than what we got with the 2-tier results. Okay, so let me go to the next slide. Was there a question? No? Okay. So this is a diagram of what it looks like. Basically, so we got the 3 tiers. The presentation tier is just the benchmark driver in this case. So this is what's generating all the load against our 3-tier setup. In the middle, we've got the application tier, which is where the vast majority of the resources were being used. And then on the back end, we have a single VM acting as the database tier. So in the middle, they're using Halem-based blades. So those are 2 sockets with 8 physical cores and 16 logical threads each. And there were 7 blades. Each blade had 2 8 vCPU VMs, meaning that they were able to use all 16 logical threads. So in the 2-tier, we only had 1 8 vCPU VM on a single physical host. Here we were able to use 2. And so by using that, we're able to take advantage of all 16 logical threads, 2 8 vCPU VMs per physical host. And then the database VM was an 8 vCPU VM running on a single dedicated host by itself with access to storage on the back. So there's a couple of details here I want to talk about. One is, in order to get the best performance, they set up a dedicated network between the client and the application tier, and then another network between the application and the database tier. So that network traffic was completely segregated on 2 different physical switches. And then there's also, at the virtualization layer, different virtual switches involved. The other thing this is kind of the virtualization specific aspect, is that when Fujitsu did the tuning for this, they used all the same best practices they would use to do tuning in a physical environment. But what they found was that they needed more dialog worker threads in order to drive the utilization up to a higher level. So an equivalent physical box, they would have used a slightly lower number of dialog threads than what they ended up using in the VMs. And we found that to be true in several instances. I'm going to talk about another example in just a little bit. So, and then this is a chart that shows the high-level kind of performance highlights of what happened during this 3-tier benchmark. So we got the SAPs, our disk I/O. The log I/O was average 1,600 IOPS, but there is a portion of the SD benchmark that is a checkpoint, a save point, sorry. And during that time, IOPS peaked at about 3,500. We also have a fairly significant amount of network traffic in the 3-tier with up to 160,000 packets per second between the application and database tier. So it's a pretty heavy workload, but we were able to get a really great certified benchmark number from it. So the next aspect of performance that comes up a lot, or is often asked, is what's the difference between virtual and native in an SAP environment? So we set up a test, and this test was done by a colleague of mine in performance engineering, Tuet, and there is a white paper published, which is linked at the bottom for more details. But she set up an environment where we really did a good apples-to-apples comparison of physical and virtual. This is using an AMD-based server with the Shanghai processors, and we did 4 tests on each, one on the native and one on the virtual side, with 1 vCPU, 2 vCPU, 3 vCPU, and 1, 2, 4, and 8 vCPU tests, and then compared those between the physical and the native. Now, it's actually kind of tricky to get a really fair or true apples-to-apples comparison test with all the ways that the servers are architected today. So one of the things that we did to make sure that we got that was we used the NUMA control parameter on the Linux side to dictate which cores were used on which sockets on the physical side. And then we also controlled that on the virtual side as well. So we were using the same number of sockets in addition to a number of physical cores. Okay. Yes, and so the criteria for this is all users that you can run maintaining less than a 1-second response time. So it turns out that native and virtual are very, very close in performance with these tests. We saw just a 5 to 7% difference across the range of tests that were run. And this is very similar to results that, this is a test that's very similar that we ran a year previous with ESX40. But with 4.1 we did see some improvement. So instead of a 5 to 15% difference between native and virtual, with 4.1 we're seeing only a 5 to 7% difference. So we're continuing to see increases in performance as we continue to improve ESX, and the hardware continues to improve as well. Okay. So this next set of tests is a 3-tier test, similar to the certified benchmark that I talked about earlier. But the difference here is that I wasn't running this as a benchmark. It was more to test scalability of a 3-tier workload. So as I continue to add workload into a 3-tier environment, how much performance would I continue to gain as additional resources were added? And we want to use a 3-tier test as opposed to the 2-tier because we're able to stress the network, and there's more significant amount of I/O because the database is more heavily loaded. So for the test configuration, used an Intel Nehalem server, actually 2 of them, and there was 1 database VM and 3 application server VMs. So those 4 VMs together was my 3-tier stack, 1 being dedicated for database and the other 3 as application servers. And I used the 1-second response time for the criteria to measure the test set as well. Okay, so this is what I call my curves chart. And every time I've used this chart, I've gotten questions. But I continue to use it. I think it's interesting. I think people like to see the curves. So what this shows is a number of concurrent users on 3 different test scenarios. And as I add users, the response time goes up. So the best part of the graph would be down and to the right. So the further you could get over and down would be the best. So as you can see, performance continues to improve across these three configurations. So the red dots in the red curve is the 4 VMs, each with 2 vCPUs, all running on a single host. The blue curve is the same 4 VMs, but this time with 4 vCPUs. And then the green line is 2 hosts. So I take 2 of the VMs and move them to a second host. They all have 4 vCPUs. So in each case, I'm continuing to give more resources to the VMs, but I'm not changing anything inside the VM itself in terms of any type of configuration settings. It's just adding additional resources and seeing how well things can scale out. So the first point here is that between the red and blue line, the only difference is that I go from using just the 8 physical cores to using all 16 logical threads on the box. So I'm basically using the hyperthreading capability of the box. And by doing that, I was able to get a 24% gain in performance. Okay? So hyperthreading gave me a 24% gain in performance. Now, the way that I was able to achieve that was there's a parameter called, we refer to as HIMP. It's halting idle millisecond penalty. And when you set that to 0, it allows our scheduler to handle the hyperthreaded or the logical processors in the box more fairly, and it will use them more actively. And so I was able to get the 24% gain. Without that, my gain was around 5% in these tests. So if you're going to be using hyperthreading, it would be worthwhile to look at the HIMP parameter when you set it. And if you Google HIMP, H-I-M-P, not H-E-M-P, you can find some blog entries. Okay, I think I was going to say something else, but maybe I'll remember. And then, so the other point I want to make here is that between the red and green lines, we're now comparing adding an additional host. So in the red case, I'm using all 8 physical cores on one box, and then in the green line, I'm using 16 physical cores across two hosts. So I've got all 8 physical cores used on one and all 8 physical cores used on the other. And by doing that, I got a 90% gain in number of users in total performance. So, which is, I think, a pretty good scalability rate just by adding additional hardware. I didn't have to do anything to my application to achieve that. Okay, I think that's it for this slide. I feel like I'm forgetting a point, and hopefully, hopefully I didn't. Okay. Okay, so the final aspect of performance that I want to talk about before I let Vas take over is batch jobs. So all the tests that I've talked about so far are OLTP based, which is a key aspect of performance. Like I said, it's SD benchmark is an OLTP based benchmark. It's very key. But there's another aspect that everybody has to run of these batch jobs. Now, every batch job is going to be different, and it's going to perform slightly different based on the customer's environment. So what types of jobs they're going to run, what their data is, how big their data is, all that is going to affect the amount of time it takes for a given batch job to run. So that's why it's difficult for us to test and give like an easy answer. But there is this SGen batch job which comes with, or it's a part of the SAP system, and what it does is it goes out and it basically recompiles all the system objects after a system update or after you've first installed SAP. So everybody does run it, but it's not something that you run like every day or every week or every month. It's a sporadic type thing. But some customers do feel that it's a fair barometer of batch job performance. But some customers tell us it's not, and it's not fair to use. And I understand that. What happened was, so I mentioned earlier, part of my job is that when performance escalations come in, ultimately they can end up with us. So we had a customer, an SAP on vSphere customer, who's reporting bad batch job performance. And so we get on the phone and we're talking with them, and they say, well, when we run SGen, we see the exact same thing. So we feel like if you run SGen, that's a fair barometer. If you can tell us how to fix SGen to run on vSphere, then that's what we want to know. So I was able to recreate basically the same type of times they were seeing with their SGen job on my system in the lab, and then started working from there. And what we were seeing was pretty long. So the batch job, what we're trying to do is get it to complete as fast as possible. So the lower the number, and these numbers are in terms of seconds, the better. So when we started off, I started off with a VM configuration similar to what they were using for their application server VMs, with 4 vCPUs, the E8000 virtual NIC driver, which is the default, and 10 dialog work processes. And it completed about 2,500 seconds. Then by going through a series of what are really kind of standard best practices in terms of implementing performance, looking at things and then implementing changes to try to improve performance, I was able to end up with a much improved result. And the key changes that we did were switching to the VMX-Net 3 networked adapter. So in this configuration, they were in a 3-tier environment. So the application server and the database server communicating to each other across the network. There's a lot of traffic. So the VMX-Net 3 driver really provides a lot better performance than the E1000 driver did, and that was a big driver of performance. After that, things actually looked fairly good in ESX top. CPU utilization was low, though. It wasn't low. It wasn't at 100%. It was like, I think, around 60% or so. So we started looking at the SAP side of things to see what was going on there. And what we saw was queuing on our dialog work processes, indicating that we should add more. So we did. Saw an increase that was pretty good when we doubled them. I then increased them again to 30. It dropped yet some more. And then, because I was running the VM at 100% at this point, I said, well, let's add more vCPUs and see if it scales even more. And we were able to get yet another gain. So at a certain point, you have to decide, do you want to have an 8 vCPU VM or 4 vCPU VM, and is the extra gain that you get worth it? But it did continue to improve some. The point is that by using performance monitoring, so looking at your performance, seeing what are the bottlenecks, both on the ESX side and within SAP itself, you can identify these performance bottlenecks and then add additional resources to address them. Okay, so a quick summary, and then I'm going to hand it over to Vas. We're doing pretty good?
Yeah.
Okay. So certified SAP benchmarks are out there on vSphere, both of the 2-tier and the 3-tier variety, show good performance. Virtual, as compared to native performance with SAP, has been measured to be very good, continuing to improve with the latest iteration. The 3-tier scalability, so as I continue to add additional resources to the VMs, continue to get more performance. And then we also found that you could achieve really good batch job performance by following best practices. So I remembered one thing. So on the SGen performance, the number that I got to at the end there was within about 5% of what the customer was reporting for their native performance with that same batch job. And then they went and did implement these same changes and saw the same thing in their environment with their real batch job. So they did achieve similar performance gains as to what I found in the lab using SGen. So in this case, SGen was similar to their batch jobs, but we understand that it may not be in all cases. Okay. And with that, I will let Vas take over.
Thanks very much, Todd. I'm going to cover kind of more like how Todd talked about the benchmark results. I'm going to briefly talk about how we use those results to size SAP on VMware. This is a big activity I kind of get involved in a pre-sales environment. Talk a bit about monitoring, and also I'm going to talk about hot add CPU, because that potential useful use case for an SAP environment. A lot of batch jobs run in SAP. They typically run at month end, so they need a dynamic environment to handle changing workloads. But before I continue, I just want to get an idea of how many people here are actually SAP basis admins. I'm guessing, okay, so ST03, OS07N, you guys go into SAP and do all that stuff. I assume the rest are VI admins. Is that correct? So a lot of the content I'm going to really cover is going to help really the VI admin talk to the SAP admin on site. Because the SAP admin typically is the very, very conservative workload, tends to be the most mission-critical app in the data center. So SAP admins, SAP business people want to see things explained in terms of SAP. So Todd mentioned SAPs. So SAPs comes up a lot. Even in the virtual world, we'll use the word SAPs. So I'm just going to go back one slide. In Todd's summary, he's covered two metrics at the top, those 6250 and 11230. That's the SAPs rating of the VM as performed in a benchmark. And those SAPs rating you can use for sizing. And what is a SAP? A SAP is a measure of transaction throughput in SAP. And it's a normalized metric that SAP have established over 10 plus years ago. And it stands for SAP Application Performance Standard. And what it means is effectively 100 SAPs equals 2,000 processed order line items per hour. And they use that figure to compare different hardware architectures and for sizing. And we're going to do that with virtual machines too. And what I'm going to show is basically how you would get a rough guesstimate to size. This is something you can do using those public results. The actual sizing you'll find is done by a hardware vendor, and I'll talk about that. They'll give you more an official sizing and architecture design. So let's look at sizing. So Todd covered those benchmark results. So here's a diagram showing virtual machines running SAP apps. We've got one running a database. There's an acronym there, CI. CI refers to Central Instance. It's a special kind of app server. It's a single point of failure. SAP architecture needs it. Then there's traditional app servers, 3-tier architecture, and somewhere out in the presentation layer there'll be a thick client. And so you can basically take the results of the benchmark to say that each little building block here, for virtual CPU is a common building block with vSphere 4.1. For virtual CPU has about 6,000 SAPs from the benchmark. 2, just divide by 2. It's from the test that Todd showed. It's pretty linear. It's linear scalability from 1 to 8 virtual CPU. So if you want to estimate the rating of a 2 virtual CPU, divide the 4-way result by 2. So that way you can devise the size of your VMs, and you can approximately say this is the amount of SAPs for each VM. Now, each x86 server, each hardware vendor certifies their x86 server with SAP, running the SAP benchmark kit. And typically they run a physical benchmark, and they produce a SAPs rating for that server. That SAPs rating, it's on a public website from SAP, www.sap.com benchmark. You can get the SAPs rating for the physical x86 server. Now, what's the corresponding SAPs rating if it's virtual? For sizing, rule of thumb, we just take off 10%. Todd showed that with 4.1, you've got a 5 to 7% overhead, but 10% is easier to divide by 10, so take off 10% as a rule of thumb. So the virtual SAPs rating of the ESX server itself is going to be the physical rating minus 10%. And then what you do is, once you've established what number of VMs you need, you stack up the VMs so the total SAPs rating of the VMs is less than or equal to the virtual SAPs rating of the ESX server. It's just a guideline to get an idea of, for example, if SAP asks, if SAP goes to the VI admin, look, I've got this amount of SAPs, how many VMs do I need? Now, the SAP business can give you the number of SAPs from a tool. There's a tool called QuickSizer. This is an online tool developed by SAP that's available online. You can log into. You enter your business requirements, say 1,000 sales order entry users, 10,000 materials, enter all your data in, and it outputs a SAPs requirement to deliver that business, and it breaks it down by app tier and DB tier. It's all standard stuff in the SAP industry. So once you have your SAPs rating for your business, you can just then determine how many VMs you need by just adding up the VM SAPs. That gives you a rough idea. Again, this is not something that's official. You would do this just as a way of probably getting an idea before you go to your hardware vendor. And then if you go to your hardware vendor, we partner with all of them. The hardware vendor will provide you a more accurate sizing. Now, each of the hardware vendors, to mention most of them, the big ones, IBM, HP, even EMC, Sun, Fujitsu, Cisco, they have SAP practices They've been around since 10 plus years. They've been sizing on physical for the last 10 plus years. This same center can now size on VMware. We've partnered with them and we've worked with them to develop sizing guidelines, and they've developed them themselves. They have VCP architects internally, and they can give you an actual sizing based on what the business requirements are on VMware. So you can go out to them and get a nice little, you'll get an architecture design. And typically what that might look like is like this. Here's an example sizing architecture from one of our vendor partners for a particular business. In this case, it was probably on the small, medium size, with total of 1,500 SAP users, and the vendor will size for every module the customer needs. Typically, the SAP flagship product is ERP, Enterprise Resource Planning, but there's loads of other products SAP has, Supplier Relationship Management, Portal, and typically a customer will need sizing for all those products. So each product is a separate database. We'll have a separate set of app servers, so it's multiple virtual machines. And then each production is supported by typically multiple non-production systems, QA development. So that's how you can see the SAP landscape proliferates. And in this case, the vendor's taken all those requirements, estimated how many servers you need. They've given you a blade and a high-level blade and storage architecture. And separate to this, they'll give you typically a spreadsheet with all the virtual machines and the size of the virtual machines, the number of vCPU and the amount of memory. The vCPU virtual machine layout, I don't have that example, but that will be in addition to this. So, and here's an example. In this case, they've recommended, and they have their own recommendations and best practices, which they build off VMware, and they actually add to what we say based on what they've seen in their labs and with their customers. In this example, they recommend a minimum of 3-node cluster. So if one fails, you still have 2 nodes left for VMware HA. And in this case, they're mixing prod and non-prod in the same cluster. You'll see for larger installations, a lot of the hardware vendors, what they might recommend is a separate cluster for production and a separate cluster for non-production. That's also viable. And a lot of the reasons for that is SAP needs a lot of memory. And as I now going to go on and talk a bit about the memory requirements for SAP and the best practices of VMware, you're going to see that with reservation settings, the memory kind of tends to be a high requirement for SAP. So I'm going to go in and talk about memory and CPU best practices, but before I do, we're going to talk about performance monitoring, because all the sessions at VMware will be going to vCenter and ESX top sessions for performance monitoring. The SAP admin will probably go there as a last resort. The first place they're going to look for performance is within their own tools. So SAP as a client-server architecture has a thick client, and you can, through the thick client, you can log into an app server, and in that app server you can access business transactions. You can also access a lot of system admin functions. And this is an example of a screenshot of one of the system admin functions. It's transaction 070N. Now, this is the transaction an SAP admin will go to if there's a performance problem which is OS related. Now, with our partnership with SAP, and also as a testament to SAP's commitment to virtualization, SAP have enhanced this transaction now to read virtual counters from the guest OS. So a lot of the key ESX top stats you're going to see in this screenshot. And how it's done is shown on the little diagram on the right, which I can't see, but I can see here. So on the right, we have a virtual machine running SAP. In a normal install of SAP, when you bring up SAP, it automatically runs a collector program called SAP OS Col. I think it's a C program. That collects performance data from the guest OS, Windows or Linux. It collects the performance data. SAP has enhanced that program now to access the guest SDK API, and it's now extracting ESX counters. So, question of... Oh, the details of that is in that note. I'm not sure. There's a note, SAP note 1409604. I think it's, I don't know. I have to look at the note. Yeah. So if you follow the note, it tells you what you need to do, which version of SAP OS Col you need to download, and also there's some configuration settings you have to do in ESX. So this screen allows the basis admin now to look at virtual memory and virtual CPU, but it's slightly different to what you might be used to seeing in vCenter, and I'm just going to cover that a bit. So let's look at memory. SAP is very memory intensive, so memory settings is a key thing for an SAP admin. There's a counter in that screen called minimum memory available. That's what they refer to as the reservation setting for the VM. SAP guideline is to set the reservation to the size of the virtual machine. It's pretty large because an SAP, typically a two-way app server would be about 8 gig of RAM, a four-way 16 gig. So they're going to set high reservation settings. And that's just an SAP conservative guideline because SAP is so mission critical. They want to avoid the chance of any ESX swapping. Now, one of the reasons is it's the nature of the SAP application. When it comes up, it grabs the memory, grabs the RAM in the guest OS, and it's permanently allocated to SAP. It doesn't give that up. And that's the memory it allocates to business users as they log on to the app server and execute transactions. So it can be considered wasteful. It depends on sort of apps you've already virtualized. So compared to other apps you may have virtualized first in the data center, you're going to see a lot of not as big consolidation ratios with SAP. But typically, that's okay because it means you'll probably end up with more hardware memory for the SAP projects. But they've been kind of used to that for the last 10 years. So with the price performance savings they get with x86, I don't think that should be a problem. So of course, the issue now is you're going to limit flexibility. If you've got memory reservations set so high, you may not be able to vMotion. If you have a VMware HA scenario, VMs may not come up. The only way it's going to come up if you've got spare memory available on the remaining boxes. So that has to be all factored into the design. And one thing to note, through that transaction OS07N, you can see the basic virtual counters. So if you have a support case, if you log a support with SAP, VMware has support staff now at SAP support. So if you log a call with SAP and it's a virtual problem, they'll hand it over to our VMware support guy. So you'll get that integrated support. And sometimes they might say, look, if you have a performance problem and I don't see that reservation set, call me back when you've set the reservation. And then, so it doesn't always happen that way, but bear in mind that they can log in and see all the reservation settings through that transaction. So that's memory. So the key thing is, because you're setting reservations, right-size the memory of the virtual machine. So when you do a sizing, you only estimate the memory for a virtual machine. Typically, I've seen for every vCPU in a VM, you allocate 2 to 4 gig of RAM. So a four-way app server might have between 8 to 16 gigabyte of RAM. That's an average. So in reality, you have to monitor the workload, see how much you're really using, and then you can do that with SAP transactions. SAP have other transactions that allow you to see the actual memory used by the application, and one of them is transaction STO2. So the SAP admin should be using that the same way they do in physical, but it's perhaps a bit more important to look at it in the VM world because you want to see if there's scope to save memory. So use STO2. Good advantage is if you're setting reservations, you don't even have to worry about the swap counters. So that's one less thing to monitor because you shouldn't be swapping. Theoretically, there should be no swapping with no memory overcommitment. You still need to monitor the guest activity within the OS. You still need to monitor the swap activity within the guest OS. So how you monitor that in physical, the same applies in virtual. So SAP needs a lot of swap space. So SAP requirements still monitor that in the virtual machine the way they do that in physical. And of course, you can definitely relax the overcommitment requirement for non-production systems, or in cases where you accurately know you can predict your workload. Maybe it's 2 app servers, one runs at night and the other one's during the day. If you can 100% predict that's going to happen, you have a possibility to overcommit. And of course, we've seen cases where the SAP customer may prefer reservations, but the VMware admin has a lot of experience and they can negotiate. Maybe there's a compromise scenario, 50% memory reservation instead. So a lot of that is not exactly fixed in stone, so it can depend. But so this is the starting point for a basis admin to do monitoring their transaction. Of course, you're going to have to hand over to the go over to vCenter for more advanced troubleshooting. Just look at now CPU. You can look at CPU usage in that same transaction, OS07N. But the thing here is SAP measures the CPU in a different metric. It measures it used with respect to number of cores used or number of CPUs, whereas in vCenter you're used to seeing % utilization. So just to give you an example, if you were to monitor CPU in the SAP transaction, I have a screenshot showing an example of something I ran in the lab. In a lab, I've got a single 8-core ESX server. Hyperthreading hasn't been activated, so it's 8 cores, 0 threads, 2 VMs configured with 3 virtual CPU each, and both running the database and an app server. Both are running a CPU-intensive load, so they're both saturated at 100%. So 3 virtual CPU kind of equates to about 3 cores. So you'll see the monitoring that SAP gives. It says that you can see in the SAP transaction that this VM, I'm logged into one of the VMs on that ESX server via the SAP client. It tells you the number of CPUs allocated to that VM, so it can see 3. Also from that VM, it can tell you how busy the ESX server host is doing. The second arrow in the middle, you can see that the actual number of cores being used by the ESX is 5.89, which is about 6, which is expected. So in this case, the administrator can log into the VM and see what the ESX server is doing as well as a whole. And of course, at the bottom, it's telling you the actual utilization of the actual VM, which is, because it's saturated, it's around 2.98 IE3. So it's just to give you an idea of what the SAP admin is going to see and also what SAP support is going to see if they log in to do any support work. And at some point, this is not enough for complete troubleshooting for CPU because you can't really effectively look at % ready. That's the metric that determines contention between VMs. There is a % ready type counter in this screen, but it's not that clear compared to vCenter. So you have to go to vCenter for that. So if we look at vCPU monitoring for SAP, obviously if the CPU is being saturated, you can check that in OS07N. They have the option to check if accidentally, if a hard limit has been set on a VM in terms of CPU, you can see that in the transaction, so you want to check that. Now, obviously, if you have a CPU bottleneck, what do you do with SAP? It's pretty straightforward. For app servers, you can just scale horizontally, add more app server VMs. That's what the benchmarking test showed. It scales horizontally. You can also increase the vCPU assignment of the individual VM. And you can do hot add is possible depending on the guest OS. And I've got about 7 minutes left. I'm just going to finish up by showing you a hot add demo. The use case for SAP is pretty much like this. We have a situation where maybe at the beginning of the month, you start off with a standard configuration of an app server which is configured to run batch programs. Batch programs are much like the SGen that Todd mentioned. And maybe it starts off at 2 virtual CPU. Then what you'll see typically with SAP workloads fluctuating, a month end comes in and the batch activity increases, so you can hot add without no downtime. You can hot add 6 virtual CPU. And then wait till month end processing completes, and then what then? At the beginning of the next month, you've got oversized app server. So what you can't hot remove, that's currently not supported, I guess, by the guest OS due to corruption. Now, there's nothing the app server in SAP is stateless. It has no data. So you can configure SAP to make sure no batch jobs run after month end. And when there's no activity on it, you can just delete it. Just delete the VM. It's an app server. Delete it. And then somewhere you already have a template app server already ready as a template. You just reprovision it. And you're ready to start up for the next month. So this was an example one customer asked about how they could address their fluctuating workloads. So I'm just going to switch to a demo that demonstrates this. I've got about 5 minutes before questions. I think, just see if this thing wakes up. Maybe not. No, his laptop's not. Hold on. Okay. This is a recorded demo, so it should work. So let me just start at the beginning. It's got to refresh itself. Okay. View full screen. It's not coming up as clear as it. The resolution's not that clear, but see if we can get through it. So, oh, here it is. So we start off with a virtual machine running SAP, one virtual CPU VM. So we see here it's one virtual CPU, it's running SUSE. It's an SAP transaction that tells you how many CPU that the app server sees. It sees 1, CPU 0. Now we just want to verify the properties of this VM, that hot add CPU is enabled. You see it's enabled, hot plug, and this is possible because I'm running SUSE 11. So this works for SUSE 11, Windows 2008. I'm not sure about Red Hat. The latest release of Red Hat may support hot add. So now I switch over to SAP. Now I've already run this batch job twice with one virtual CPU, and it finished in 125 minutes. I ran it twice to make sure. So now what I'm going to do is I'm going to kick off a third job, the same job now, and in the middle of the job I'm going to hot add. So I hope I should not see any corruption of the job while I hot add. So I'm just kicking off this job. This is the famous SGen job, the system admin job that generates a lot of CPU and database I/O. So I kick that off and start that, and I can then monitor the job in SAP. So now if I click refresh, I'll see that third job kick off. It's active, and now while it's active, I'm going to switch over to vCenter and hot add, change it from one virtual CPU to 3. So just go in, it'll allow me to hot add, and you'll see there I can hot add, change it to 3. The batch job is still running. Now I switch over now back to the SAP GUI that's monitoring the job. It's completed, adding the 3 virtual CPU. And we'll see when I go back that the job is not impacted, it's still running. And because I went from 1 to 3, I expect to see this job to run quicker, because I managed to do the switch towards the beginning of the job. So let that run. I've got a couple of seconds. It should finish. The key thing here, this is, as Todd mentioned, this is that system admin job, but it does run like other key business jobs, like MRP runs, supply chain management. They have all these complex batch jobs that run like this. And let it run. And there, now you see it finished in 69 seconds, 70 seconds compared to 125. But I did the hot add in the middle of the job while it was running. So no corruption. It handled it quite well. We can just re-verify now that SAP sees 3. When I click on it, it'll show 3. So I'm just going to switch back. So I'm just wrapping up now. We've talked about the performance benchmarks, sizing, performance monitoring, which is for, there has to be some kind of handshaking going on with the VI admin and the SAP admin. There are existing notes available. The SAP admin can download that go into more detail about SAP on VMware. There's some, as Todd mentioned, everything's supported. We have a few caveats. They're in those notes. Speak to your SAP admin. The SAP admin will pull those down. And there's a couple of papers that we refer to. There's a best practice paper that goes into more detail. It covers all the best practices for SAP on VMware by memory, vCPU, disk storage. And there's also that's a great reference, the troubleshooting guide, which I think most VI admins are aware of. And there's an SAP Alliance site. If you want to see what other customers have been doing with SAP with VMware, there's reference stories on that website. Well, thank you. That concludes my piece and the presentation. So, any questions?